Welcome to the next installment in a series of GIS tutorials geared towards local officials on how to use FEMA base-level engineering datasets in GIS to support flood hazard mitigation decisions. This tutorial series was developed by the Water Institute of the Gulf in partnership with FEMA Region 6 through FEMA's Cooperating Technical Partners program. In today's tutorial, you will learn how to download data from the estimated BFE viewer, and we'll discuss the specific types of data available for download as well as their utility. Today's tutorial has three primary learning objectives. First, we will review how to navigate the estimated base flood elevation viewer application to locate base-level engineering data for the watershed you're interested in. Then we'll do a shallow dive into the specific types of data available for download, from hydrologic and hydraulic models to raster modeling products and vector-based map data. Finally, we will discuss open source and publicly available software resources to work with and manipulate BLE data. You can launch the Estimated Base Flood Elevation Viewer application by navigating to the above URL, scanning the associated QR code, or by entering BFE Viewer as the search term in your favorite search engine. The splash screen of the Estimated Base Flood Elevation Viewer application includes some disclaimer language regarding the intended use of BLE data products. It is important to understand that the products and data available through the application are the result of automated modeling routines that leverage high-resolution ground data. While these products meet FEMA's requirements for flood risk studies, they are intended to supplement rather than replace regulatory flood insurance rate maps as best available flood hazard information. After acknowledging the splash screen, you are presented with three navigation options. To directly download datasets and models, select the Download Datasets and Models option. This will open a single window viewing interface showing the study areas that have data packaged and available for download. The other navigation options have been discussed in previous tutorials. After selecting the Download Datasets and Models option, you are directed to a mapping frame detailing the availability of BLE data by specific 8-digit HUC. Watersheds detailed with dark greens colored symbology have BLE data products currently available for download. Watersheds shown with turquoise colored symbology are currently in the data preparation process. Downloadable data for these watersheds will be available in the future. Check back weekly if your data through your watershed hasn't been published yet. You can navigate the mapping frame by clicking and dragging to change its extent, and by using the scroll wheel to zoom in. If preferred, you can zoom in using the on-screen buttons. Click the plus button to zoom in, or click the minus button to zoom out. Once you have navigated and zoomed to your area of interest, hover the cursor over a watershed to identify it and open the Data Download dialog. Then select the green Download Data button to open a table that lists the availability of downloadable data. After clicking the Download Data button, the user is presented with a dialog detailing available data. In total, there are 7 datasets available for download. Users can download the HEC-RAS models, water surface elevation grids, flood depth grids, or the vector file containing a geodatabase of floodplain extents, model cross-sections, and streamlines. An option to download the table is also given. Selecting this option will generate an Excel file with hyperlinks to all the datasets. The hyperlinks presented in the workbook are direct links to the location of the dataset in the relevant Amazon Web Services S3 bucket. Let's take some time to break down what all these datasets contain. All datasets are downloaded as a zipped archive. The first dataset in the table contains the HEC-RAS models for the watershed. This dataset has a file name in the format huc8_models. The contents of the archive include the HEC-RAS hydraulic models for all streams studied in the base level engineering assessment. It is important to note that detailed models from firms are not included. The next dataset in the table contains rasters for the 1% event depths, 100-year flooding events. This dataset has a file name in the format huc8_depth01. The contents of the archive include flood depth elevations in a raster format for the 1% storm event. Below that, the next entry details rasters for the 0.2% event depths, 500-year flooding events. This dataset has a file name in the format huc8_depth002. The contents of the archive include flood depth elevations in a raster format for the 0.2% storm event. The first entry below the event depths includes rasters for the 1% event elevations. This dataset has a file name in the format huc8_elev01. The contents of the archive include top of water surface elevations in a gridded format for the 1% storm event. The following entry in the table details rasters for the 0.2% event elevations. This dataset has a file name in the format huc8 underscore ELEV002. The contents of the archive include top of water surface elevations in a gridded format for the 0.2% storm event. The second to last entry in the table is titled Vector Spatial Data. This dataset has a file name in the format huc08 underscore vector data. The archive contains a zipped geodatabase with a collection of spatial data used or created during the BLE assessment. The final entry in the table contains relevant reports and documents associated with the watershed's BLE assessment. It has a file name in the format huc08 underscore documents. It includes the BLE report that details terrain, hydrology, and other modeling details. It may also include work maps, as well as KMZ, that is Google Earth files, if they were created. The vector geodatabase contains several feature datasets and dependent feature classes. Feature classes named ending with an underscore LN are generally line vectors, whereas names ending with underscore AR are polygons. In the base feature dataset, there's a feature class named either S underscore Paul underscore AR or S underscore FRD underscore Paul underscore AR. This feature class documents political boundaries for counties, parishes, towns, cities within the study area. In the same base feature dataset, there is also a feature class named S underscore HUC underscore AR. This feature class contains the watershed boundary defining the extent of the study area. The CNMS feature dataset contains two feature classes, named S underscore studies underscore LN and S underscore unmapped underscore LN. The studies feature class details stream center lines per study streams and includes information about current firm flood zones. The unmapped feature class documents stream center lines outside the BLE studies limits. The eBFE dataset contains several feature classes. The DET underscore STUD underscore LN and DET underscore STUD underscore AR feature classes show the detailed Zone AE and Zone VE study areas shown on the current effective firm. In these areas, users should consult and review base level engineering results against the base flood elevations shown on firms prior to use of the BLE data alone. The feature class named subbasins contains the drainage areas used for the hydrologic analysis in the watershed's BLE assessment. The feature class titled S underscore WTR underscore LN details stream center lines within the study area, whereas the S underscore WTR underscore AR feature class contains polygons of ponds and lakes within the study area. The S underscore FLD underscore HAZ underscore HAR feature class details the polygon floodplain extents determined in the BLE study. The file includes estimated floodplain extents for the 1% and 0.2% annual chance floodplains. In a GIS, these can be categorized using the EST underscore AR underscore ID field. 1% is denoted with high and 0.2% is denoted with moderate. All other areas that aren't included by this feature class should be understood to be low flood risk during the 1% and 0.2% events. The 10% underscore FP feature class contains polygons of estimated flood extents expected during the 10% annual chance storm event. A 10% event is associated with a smaller rainfall occurrence and is likely to occur more frequently than the 1%. The XS underscore 1D feature class details the location and orientation of all analysis cross-sections that were used in the BLE assessment. It is available for all 1D analysis areas prepared. If the file is not available, analysis was performed in 2D. The BFE underscore 2D feature class contains BFE polylines created from the water surface elevation grid. It is primarily intended to assist viewers to determine flow direction and provide information for estimated BFE viewer. The mitigation feature dataset contains three feature classes, S underscore AOMI underscore PT and S underscore AOMI underscore AR indicate areas where additional information could refine the BLE results. The S underscore FRAC underscore AR or S underscore census block underscore AR feature class is the spatial foundation for all census block based flood risk assessment data. Damage estimates for flood risk assessments performed at the census block are stored in this dataset. The following tools can be used to help interact with downloaded BLE data. To download HECRAS software, visit the Hydraulic Engineering Center website and navigate to the software page, or paste the link detailed in the slide into your web browser. If you need assistance understanding HECRAS modeling and associated spatial data, FEMA provides some useful resources. How-to tip sheets are available in the FEMA's media library at the link shown in the second bullet. You can also locate them by typing how to find the right HECRAS model or how to find the right spatial file in your preferred search engine. To read geospatial data, Esri provides a free work called ArcReader that allows you to view and interact with GIS files. It can be downloaded directly at the address detailed in the third bullet or by searching for ArcReader. There are several additional open source GIS programs available, QGIS being the most prolific. Details regarding HECRAS and other data shown on firms is available through FEMA's engineering library at fema.gov/engineering library. Today's tutorial covered 3 primary learning objectives. We reviewed how to navigate the estimated base flood elevation viewer application to locate base level engineering data. We covered the specific types of data available for download, from hydrologic and hydraulic models to raster modeling products and vector base map data. And we discussed open source and publicly available software resources to work with and manipulate BLE data. Thanks for tuning in.